Hello, guys. Good afternoon. Hello, everyone. Aditya, Ranganath, Krishna. Are you getting me? Can you see the screen now? Hello, everyone. Please type in your name in the chat box. All of you, please type in your name in the chat box. Krishna, Ranganath, Shomik, Keer- Kirtana. Hello, Kirtana. How are you? Sri Ramagiri, Aditya, Dhyan Shesh, Bala Murugan, Ranganath. Guys, all of you, please type in your name in the comment box. We'll start the session very soon. Skanda, Sahana, Ananya, Anurag, Ravikiran, Ronak. Okay, guys. So this session is a YouTube live session. Okay. In case of any doubt, you can use your chat box for whatever doubt you have. Okay. So you cannot. No, I'm not hearing you. Right. So whatever doubt you have, you write it down in the comment box. Then we can discuss that. Right. Okay. So I guess most of you have joined already. Ronak, Vibhav, Srimagdi, Vinaya, Ananya, Abhishek, Srishti, Aditi. Okay, guys. So last class, I guess we have discussed about the reduction. Sorry, the balancing of redox reaction. Yes or no? We have discussed about the balancing of redox reaction, guys. Okay. So any one of you have any doubt in the balancing of redox reaction? Any doubt if you have, you can ask me here. We'll discuss that first and then we'll move on to the class. All of you understood how to balance the reactions, redox reaction in different mediums, whether it is acidic or basic medium, right? Okay, so right. Okay, so the first thing that we are discussing this redox reaction to understand the calculation of n factor in reacting condition, right? Because n factor, like I discussed already, is nothing but the valence factor, right? So if you have to find out the equivalent weight, okay, and whatever guys I'm writing down here on the screen, you have to write it down on your notes. Okay, so copy the notes properly like you always do in the class, offline class. Okay, so like I said, equivalent weight, to calculate equivalent weight, this is equals to the molecular weight of the given compound and divided by the n factor or valence factor, we call it as. This is the formula we have. Correct. Now this n factor, valency factor, in case of acid it is basicity, in case of base it is acidity, In case of salt, it is either positive or negative charge, total positive or negative charge. All these things I have discussed. Okay. Those who are not there in that particular class, you can go through your notes. Okay, it's given there, right? N factor is nothing but basicity in case of an acid, for acidity in case of a base, and when you have a salt, it is nothing but the total positive or negative charge. Correct? But I have also told you this thing, that in reacting condition, to understand the N factor, you should know what is redox reaction. Correct? So today in this session, we are going to discuss the calculation of equivalent weight, or N factor we can say, because when you have N factor, you can calculate equivalent weight. Okay. So basically in this session, we are going to understand the calculation of equivalent weight or N factor in reacting condition. Okay. So first of all of you write down the heading here, that is calculation of, sorry, calculation of equivalent weight in reacting condition. In reacting condition, right? This is the first topic we have here. Got it? Guys, again, I'm telling you, in case of any doubt, okay, I am not hearing you, right? So, with all honesty, I expect in case of any doubt, you use your chat box, write down your doubts. Okay, that only I can, respond. Okay, so in case of any doubt, write it down in your chat box. We'll respond to that. Okay. So the first thing, in case of when we have reacting condition, what we write in reacting condition, all of you copy down this. The equivalent weight in a compound, for a compound may change as per the reacting condition, as per the reaction, basically, I'll write. Okay, as per the reaction. May change as per the reaction. Okay, so depending upon the reaction, what is the change in equivalent mass and all those we have, change in oxidation number we have, according to that the equivalent weight will change, or N factor will change. Okay, and when this N factor changes, see here, when this N factor changes, right, equivalent weight will also change for the molecule, right? So first of all, I'll write down one compound here, one reaction here, right? And the reaction is this. Suppose the first reaction, I am writing it down. It is S2SO4 S2SO4 plus 2NaOH. It gives Na2SO4 plus 2H2O. Right, guys, I know there was a noise in the background because of some work is going on in the office. Okay, it will be fixed in few minutes. Okay, so you have to bear with that. Okay, so this is the reaction we have. Now we know one thing: when the two compounds reacts, they must have equal number of equivalents. Correct. So this the next point I'll write down here. The next compound is, you write down the next note over here, that, and I have discussed this, right? That when the two compound reacts, they must have equal number of equivalents. They must have equal number of equivalents. This thing we know, right? This is very important point we have. And because of this only, like if I give you a quick recall here, we have discussed about NH3, right? The equivalent mass of NH3 will be what? That will be the equivalent mass of nitrogen plus that of hydrogen. And how do we calculate that? That we know nitrogen and hydrogen are combining. So the number of equivalents of nitrogen must be equals to the number of equivalent of hydrogen. Okay. Similarly, here also, since H2SO4 and NaOH is reacting, the number of equivalents of H2SO4 should be equals to the number of equivalent of NaOH. Number of equivalent of NaOH. Okay. N factor for H2SO4 we know, right? N factor for H2SO4, it is an acid, and N factor for acid is nothing but its basicity, which is nothing but the number of replaceable H plus ion. So N factor of H2SO4 is 2. N factor of NaOH we also know, and that N factor is 1. Right? What I said, the number of equivalents of H2SO4 and NaOH must be same. Right? This one we can understand from this. You see, first of all, this is again very important formula of calculation of number of equivalents. Okay, so what I write, the formula of number of equivalents is equals to what? Is equals to the given mass divided by equivalent mass. Anyone has any doubt in this particular formula? Let me know. If it is clear, then please comment. CLR in the comment box. If it is clear, then please comment CLR in the comment box. If you have any doubt in this particular formula, let me know. Otherwise, please comment CLR in the comment box. All of you guys, quickly. What do he mean by, what is equivalence you are asking, right? Number of equivalents is nothing but see, the number of equivalents, I have discussed all this. Okay, so I won't go into detail of all this. I'll just give you a quick revision of it. Number of equivalents is the amount that combines with 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine or 108 gram of silver. This one I have discussed in the first class, Abhishek. Okay, so if you are there, then please revise your notes. You will understand what is one equivalence. Okay, and equivalent mass is the mass of one equivalent, right? That's the thing. So this equivalent mass is nothing but the molecular mass divided by N factor. So this expression we can further write. This expression we can further write given mass divided by equivalent mass is nothing but molecular mass, and this is divided by the n factor, okay, in the denominator. Okay, further this expression becomes you see, we can write given mass divided by molecular mass into n factor, right? So given mass by molecular mass is nothing but the number of moles, correct? Moles into n factor, right? All of you copy down this. So the formula of number of equivalents is equals to the given number of moles into n factor. Is it clear? This formula you understood? Please let me know. Yeah, it's look nice, right? So this is very important formula actually. Number of moles, number of equivalents is equals to the moles into n factor. Now I am coming back to this reaction which I have written over here, right? Now you see the reaction is balanced. Reaction is balanced, correct? So what is the number of moles of H2SO4 here? If you see the number of moles of H2SO4, here it is nothing but 1 mole. 1 mole of H2SO4 reacts with 2 moles of NaOH, right? So according to this formula, if you calculate the number of equivalents of H2SO4, that will be the number of moles into n factor. 2 into 1 is nothing but 2. So we have 2 equivalents of H2SO4, and here also 2 mole into n factor, that is 1, 2 equivalents of NaOH. So again you see the number of equivalents of H2SO4, here is 2 equivalents, and similarly for NaOH also it is 2 equivalents. The same thing we have, that when two compound react, they must have equal number of equivalents. Got it? Guys, understood? Okay. Okay. Can we move on? Can we move on? Please let me know, guys. Any one of you, if you feel any difficulty, please let me know. Yeah, hi Arpita. Yeah, I'm going a bit slow today, guys, because this is your first online session, right? So I'd want all of you to be very comfortable with this. Okay. Sahana is there. Sahana, are you there? Did you understand this? Because you are not there in that class when I discussed all these. Sahana, if you're there, let me know, please. Okay, yeah, that's good. Okay, guys. So two things again. I want you to understand here. Yeah. Okay. So you see this H2SO4, I have taken the n factor 2 here, right? Because both the hydrogen is taking part in the reaction. And that is why we get Na2SO4 here plus 2H2O, right? That's why I wrote n factor for H2SO4 is 2. The basicity of H2SO4 is 2, but it is possible in a given reaction condition that its basicity can be 1 also, right? So that is the next thing that we are going to discuss here. So I am moving to the next uh, slide here. Suppose the second reaction I'll write down, and which is this. Suppose the second reaction I'm writing down here, which is H2SO4, H2SO4 plus we have again NaOH, and this converts into NaHSO4 plus H2O. The reaction is balanced, guys. Please let me know this. Whether the reaction is balanced or not. Is it balanced? I guess yes, right? Quickly. Correct. So now the next thing, can you tell me in this reaction, what is the N factor of H2SO4? What is the N factor of H2SO4? N factor of H2SO4, guys. Shrishti, Aditya, Krishna, Kirtana, Dhyan, all of you are saying 2. Shamik is saying 1. Aryaman is saying 2. Is it 1 or 2? Skanda is saying 1. Sahana 2. Ronak 2. Pranjana 2. Okay, most of you are saying 2. Few of you are saying 1. Okay, guys, so answer for this thing is 1. Right? Answer is 1. Why? Because out of the 2 hydrogen here, only 1 hydrogen is taking part in the reaction. And that is why it is forming NaHSO4. The previous reaction, you see, the previous reaction, the product is Na2SO4, which means both the hydrogen is taking part in the reaction, and sodium displaces the hydrogen from here, H2SO4, and forms Na2SO4 in the first reaction. But since we have one NaHSO4 here, it means this we can write what? H plus plus HSO4 minus C. Other things you try to understand here. Okay, I'll just write it down here. See, H2SO4 has basicity 2. It means it can displace maximum 2 hydrogen. But depending upon the reaction condition, it can displace only 1 hydrogen also. Like, for example, this H2SO4, one possibility is what? It will, it may dissociate as this. It gives you 2H plus and SO4 2 minus. This is one possibility, which was happening in the first reaction. Second possibility is what? It gives you H plus and HSO4 minus. That is also second possibility we have. So when the dissociation is like this, it means its basicity is 2, n factor is 2, because 2H plus is coming out in the solution. But where here we have only one H plus, so here the n factor is 1, because only one H plus it is releasing. Correct. So when you look at the reaction, the first reaction, it is because of this kind of dissociation, and this reaction is because of this dissociation. So when you have H plus and HSO4 minus, this Na plus combines with HSO4 minus and forms NaHSO4. And H plus combines with OH minus forms H2O. That is why we are getting NaHSO4 here and H2 here. This product is possible only when this H2SO4 releases one H plus ion, and that is why its N factor is 1 here. And for NaOH, its N factor is again 1, because it is releasing OH minus ion. N factor is again 1. Right? So if you see the number of equivalents of H2SO4, since it has 1 mole of H2SO4 reacts with 1 mole of NaOH, right? And that is why the number of equivalents of H2SO4 is 1 equivalent here, and the number of equivalents of NaOH is again 1 equivalent here, because they must have equal number of equivalents. The formula we have n factor into number of moles, so 1 into 1 is 1, and again 1 into 1 is 1, so both has 1 equivalence here in this reaction. Is it clear, guys? I'm sorry, just a second. Okay. So I'll write down the reaction was this. The second reaction was this. I'm sorry. The reaction was this: H2SO4 plus NaOH. It gives NaHSO4 plus H2O. The number of n factor of H2SO4 is 1 here. I have discussed this already. N factor is 1. We have 1 mole of H2SO4 and 1 mole of NaOH. Hence, when you calculate the number of equivalents for H2SO4, we have 1 equivalent, and same for NaOH, we have 1. Right? So with this two example, we can surely say this, that in reacting condition, the n factor or the number of equivalents, right, for a given compound depends upon that what kind of reaction is taking place, right? Generally, when you have H2SO4 present like this, then its n factor is 2. But in reacting condition, its n factor depends upon the type of reaction that we have. Is it clear? Clear, guys? Now, so far, the formula of number of equivalents, we have discussed 3 different formulas. Okay, to sum up this, I'll write down all those formula, and you must write it down because all these formulas are very important. So, 3 different formula of number of equivalents we have discussed. So what we can write, the number of equivalent is equals to, the first formula we have is the given mass divided by equivalent mass, which is again equals to which is again equals to normality normality into volume in liter, and the third one is the given number of moles into n factor. These are the three different formula of calculation of number of equivalents. Okay, right? This is the formula we have. Okay, very important formula. So if you have normality, see this, if you have normality given and volume given, then we use this formula. N into V gives you number of equivalents. Given mass, by equivalent mass, we can find out number of equivalents. If number of moles you know and N factor if you know, then also you can find out the number of equivalents. Correct? Okay. Okay. Now one more thing here, you see, when I write 1 mole and 1 mole, this you have to be a bit careful over here. To write the number of moles, the reaction must be balanced. That's the condition we have. If the reaction is unbalanced, if it is not balanced, then we cannot write down the number of moles here. The exact number of moles. You can write it down, but you'll get the wrong answer. To know what exact moles are reacting, for that the reaction must be balanced. Clear? One or two more reaction we'll see. Okay, to understand this particular thing, one more reaction we'll see. You see this reaction, the third one I'll write down. Suppose we have Na2CO3. You have to solve this, guys, all of you. Na2CO3 plus HCl, 2HCl. And this gives 2NaCl plus H2O plus CO2. This is the reaction we have. Now you tell me, what is the number of equivalents of Na2CO3 we have? Because both will have the same number of equivalents. Okay, tell me this thing. All of you understood my question? Done, guys? And number of equivalents, you are saying two equivalents. All of you are getting two? Yeah, I think all of you are getting two. Most of you are getting two. Somic is getting one. Somic, is it one? See, again, Na2CO3 we have, right? So it is a salt, right? It is a salt. So its N factor is what? For salt, the N factor is the total positive or negative charge, right? So for this, the N factor is 2. And for HCl, the N factor is 1, right? So number of equivalents for this equals to what? We can write number of equivalents from this formula, because we know N factor, right? And we know the number of moles. The reaction is balanced. So for Na2CO3, we have 1 mole. The number of equivalents is what? Moles into N factor, which is 2. So we have 2 equivalents of both Na2CO3 and HCl. Answer will be 2. Correct, guys? Okay. Okay. Next one is you write down the equivalent weight. Second condition we are talking about. This is one part. Now the second one you write down. We have to discuss this also. The equivalent weight of oxidizing oxidizing and reducing agent. Reducing agent. For different cases, we use different method to find out the equivalent weight in a reaction. Okay. Okay. Now, in this, there are three methods basically to find out the equivalent weight of an oxidizing or reducing agent. There are three methods. Okay. So we'll discuss all three. Whatever you feel easy, you can use that. Okay. So you see, uh, suppose I'll write down the reaction, and the reaction is this. We have, I'm sorry, we have K2Cr2O7, which is an oxidizing agent. K2Cr2O7, guys, it is a strong oxidizing agent. Plus 4H2SO4. This is the reaction, it will be given in the question. Okay, so you don't have to worry with the reaction. Gives K2SO4 plus Cr2SO4 whole thrice plus 4H2O, and we'll also get some nascent oxygen. This oxygen, whenever you write oxygen like this, it is we call it as nascent oxygen. Okay, so this oxygen is what it is, nascent oxygen. Okay, now suppose this reaction is given, we have to find out the equivalent mass of K2Cr2O7, because this is the oxidizing agent. Clear? K2Cr2O7 is the oxidizing agent. We have to find out the equivalent mass of this. Okay, right. So what we can do, you see, whatever the molecular mass of K2Cr2O7 we have, okay, suppose that is M, molecular mass of K2Cr2O7 is M, and that we can find out M, which is nothing but if you write down the exact value, it is around 294 0.2 gram is the molecular mass of K2Cr2O7. Is it single oxygen atom? No, it's not single. Asha, you calculate, you count the number of oxygen atom. This side it would be 7 plus 16, 23 oxygen. This side we have, and this side we have 4 plus 12, 16 plus 4, 20. This must be 3 oxygen. I'll discuss what is nascent oxygen. We'll discuss. First of all, you understood this. We should have 3 oxygen atom here. Correct? Now, what is nascent oxygen is, see, oxygen is a diatomic molecule. Correct? So, in nature, it exists in this form, O2. It exists in O2. But how this oxygen molecule forms, that's the question. Right? So, nascent oxygen is the oxygen atom when it is born, when it is actually formed. What happens actually, first we get one oxygen atom and then we get another oxygen atom. Right? So, whatever oxygen atom we are getting, the time when it forms, the moment when the oxygen atom is formed, just a second. Yeah. So the moment oxygen atom formed, at that particular time, it is known as nascent oxygen. Clear? Now, oxygen atom, just a second again. Okay. Now, oxygen atom is actually not stable in its atomic form. That's why it converts into molecular form and it becomes diatomic molecule. Okay, diatomic molecule. And why, now the question is why oxygen atom is not stable, right? That is a different part, we'll discuss that later. Okay, but what is nascent oxygen? The answer is the moment oxygen atom forms, right, that at that moment it is known as nascent oxygen. Okay, and it combines with the other oxygen atom and forms a diatomic molecule, which is O2. Correct? I hope it is clear now. Yes, Srishti. Okay. Now the next thing is what? Our purpose is to find out. Just a second, guys. Our purpose is to find out the equivalent mass of K2Cr2O7. Correct. So you see, whatever molecular mass of this, that is 294 gram, when it reacts in this condition, it gives how many gram of oxygen atom, nascent oxygen atom. If you calculate the mass of this atom, oxygen atom here, it will be 3 into 16. That will be 48 gram of oxygen atom we are getting. So what we can write here in the next line is 48 gram of oxygen, 48 gram of oxygen formed by m gram, which is nothing but the molecular mass, which is 294.2 gram, m gram of K2Cr2O7. Right? 48 gram, for 48 gram we required, this is the mass. For 1 gram we required m by 48 gram of K2Cr2O7, and hence for 8 gram. Why 8 gram? Can you tell me, guys, why I'm taking 8 gram of oxygen atom? For 8 grams, it requires m by 48 into 8, that is m by 6 gram of K2Cr2O7. Right? So this method is method 1. This is method 1 with respect to with respect to the mass of the oxygen atom we are getting. Okay? Yes, why we are taking 8 gram of oxygen? Because 8 gram is the equivalent mass of oxygen atom. It is the equivalent mass of oxygen. Right? Since one equivalence combines with one, so obviously one equivalent of oxygen atom that produces with one equivalent of K2Cr2O7. Now you see in this condition, the K2Cr2O7, the equivalent mass is what? M by 6. And this becomes, 6 becomes the N factor of K2Cr2O7 under this reacting condition. Is it clear? Is it clear, guys? Clear? If it is clear, write down CLR. Did you write it down? All of you have copied this, right? Now you see method 2. That is oxidation number concept. This concept is oxidation number concept. Okay. Now you see the reaction we have here is nothing but this. In this reaction, Cr2O7 2 minus converts into Cr3 plus. That's the conversion we have, right? So I'll write down the reaction first here. And the reaction is this, that Cr2O7 2 minus converts into 2Cr3 plus. That's the conversion we have. It's clear? Cr2O7 2 minus converts into 2Cr3 plus. Yeah, for the first method, you must have nascent oxygen. If it is an oxidizing agent, you must have nascent oxygen present on the other side. You must have that. Correct, Vibhav? If you do not know the mass of nascent oxygen atom, then you cannot find out from the first method. Correct, Vibhav? Okay. Now, can you tell me, guys, what is the oxidation state of this chromium atom here? For this chromium atom, what is the oxidation state? For this chromium, it is plus 3 already. Tell me. No, any other product we cannot use trypan because for other product, the equivalent mass we do not know. Again, why we are using oxygen there? Because we know the equivalent mass of oxygen, that is 8 gram. Understood, Tripan? Yeah, correct. So here the oxidation number of chromium is plus 6 and here it is plus 3. Now, what is the total charge here on this chromium atom? That will be what? 2 into plus 6. The total charge here is 2 into plus 6. That will be plus 12. Oxidation number is this, oxidation state is this. And here the total charge will be 2 into plus 3, that is plus 6. Right? Now, according to this method, the formula of equivalent weight is this. Equivalent mass is equals to the molecular mass divided by the change in oxidation number of, if it is oxidizing agent then oxidizing agent, or reducing agent per molecule. Per molecule, what is the change we have in oxidation number and of oxidizing agent and reducing agent? That will be the uh, n factor in this case. Okay, you see molecular mass. Suppose that is m. That is what we have assumed already. Divided by the change in oxidation number is what we have plus 12 here and plus 6 here, right? So if I write down here the change in oxidation number per molecule, we have only one molecule of Cr2O7, so that will be equals to plus 12 minus plus 6 divided by 1, which is nothing but 6. And that is why the equivalent mass is equals to m by 6. Again, you see you're getting the same answer. Got it, guys? This is oxidation number concept. Any doubt till here? Any doubt till here? So how didn't we separately calculate the oxidation number of chromium? We are calculating the oxidation number of chromium only. This is the oxidation number of chromium only. Swamik, I'm not getting you. What are you asking? Asha, per molecule is what? We have only one present, the one molecule of Cr2O7 we have. That's why we have one here. If you have two Cr2O7, 2 minus, we'll write here this minus this divided by 2. That's what. Understood, Asha? Swamik, I didn't get you. We are calculating the oxidation number of chromium itself. Is it clear, Asha, with you? Per molecule? Yeah, it's potassium dichromate only because this Cr2O7 is coming from K2Cr2O7. Okay. So in K2Cr2O7, you see, in K2Cr2O7, the oxidation number of oxygen and potassium is not changing. It is only for chromium, right? So n factor of this molecule will be the n factor which we calculate with respect to chromium. That's why it will be molecular mass of K2Cr2O7 divided by the change in oxidation number of that particular atom. Yeah, two molecules of Cr we have this side, Prajna. We have two molecules this side. For this side, if you write, the equivalent mass of this particular salt, that will be molecular mass of this divided by equivalent mass of this. And there we take 2 here. We don't take 1 over there because we have 2 Cr2O cells. We are calculating the equivalent mass of either oxidizing agent or reducing agent. So K2Cr2O7 is the oxidizing agent. That's why we are taking 1 here, because we have 1 molecule of K2Cr2O7. Yeah, why chromium we are taking triple? Because only the oxidation number of chromium is changing. Is it fine? Is it fine? I want CLR. I want CLR from all of you. Quickly. Here's the M is the mass of, yes, it is the mass of K2Cr2O7. I'll write down. Molecular mass of K2Cr2O7. Method 3. And this is electron concept. Electron concept. Now, again, I'll write down the same reaction, which is nothing but this Cr2O7, 2 minus, and it converts into 2Cr3 plus. Now, the job here, we have to find out the number of electron exchanged, right, in this reaction. The number of electron exchanged. Now, for this method, the formula of equivalent mass, I'll write down the formula first. The formula of equivalent mass, whatever method you use, the answer will be m by 6 only for this particular reaction. And that will be again the molecular mass of K2Cr2O7 divided by the number of electrons exchanged, that is also per molecule. Number of electron exchanged per molecule. This is the formula we have. Now, molecular mass is m. We are fine with it. The only thing we have to know is what? How many electrons are getting exchanged here, right? To find out this, you have to balance this reaction. The reaction, you see, it is given in acidic medium, H plus. Okay, H plus. The previous reaction you see, there we have K2Cr2O7 plus H2SO4. So balance this reaction, which is in acidic medium, and tell me how many electrons are exchanged per molecule. Yeah, it's almost same, Swami. That's why we'll get the same answer. I want you to balance this reaction and tell me how many electrons are getting exchanged. Quickly. We're getting 6 electrons, right? When you balance the reaction, you're getting 6 electrons, right? How do we balance the reaction? The reaction is an acidic medium. So first of all, the chromium is balanced. We have 2 chromium this side, 2 chromium this side. Now next is what will balance? Will balance the oxygen atom. And for that we have to add 7 H2O this side and 14 H plus this side. Okay, so total positive charge is plus 12 this side and plus 6 this side. So we have to add here 6 electrons. Correct? We'll get 6 electrons. Hence, the number of electron exchanged per molecule is 6. This 6 because we have one molecule, so 6 divided by 1. So the equivalent mass from this formula will be again m divided by 6. So from all these methods you see, we are getting the same answer. Yes or no? Understood, guys? So for any oxidizing and or reducing agent, we can use any one of these methods to find out the N factor or equivalent mass. Correct? So whatever method you feel easy, you can use that method to solve the questions. Got it? Okay. Now moving to the next part here. Few reactions I'll write down and we'll see how this change is there. Okay, how to find out the equivalent mass in all this, right? Now next thing you see, all of you have copied it down. Can I move on to the next? Can I move on to the next slide? Again I am repeating, whatever I am writing it down, all of you must copy this. Okay, so you see the next reaction. How do you find out N factor here? Okay, for example, you see this reaction MnO4 minus we have MnO4 minus, and this converts into Mn plus 2. The medium is acidic, Mn plus 2. We have to find out the N factor for this reaction. N factor. Right? Now to find out N factor, what we do, you see. First of all, the medium is acidic, so you can easily balance the reaction. And then you can check the number of electron exchanges. Can you tell me the N factor? Okay, you try this one. We'll discuss then after. You'll try this one and then we'll discuss this. N factor, you tell me. Is it 1? Shamik is getting 1. Rajna is getting 1. Tripan is getting 5. Shivlela is getting 5. Aditya, Ariman, Ashish, most of you are getting 1. Okay. The one thing is what? We can find out the oxidation. We can find out the change in oxidation number per molecule, right? So Mn plus 2 we have this side. Here the oxidation state of manganese is plus 7, right? So what is N factor? Change in oxidation number per molecule, that will be plus 7 minus plus 2 divided by 1, which is nothing but 5. N factor is 5. The another way, we'll do it quickly. You can balance this reaction. Suppose we have Sharat. 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 When this work get over, this drilling thing, when this drilling gets over,
Another
10 15 minutes.
Yeah.
Okay, because the class is getting disturbed.
Yeah, another 10 15 minutes will take. After that, they'll go after this.
Okay, no,
Sure.
Yeah. Okay, so you see the reaction is this. So I'll write down the reaction quickly, and then this for this one I am doing this balancing one. Okay, it is not required here, but just to make you understand. Mn plus 2. Now, when you balance this quickly, I'll write down 4H2 on this side, right? Then 8H plus this side. Fine. So we have 7 positive charge and 5 positive charge. To do that, we have to add 5 electrons this side, and that is why the number of electron exchange per molecule is 5 and N factor is 5. Got it? So this is what the another method we have. This is the oxidation number concept. Okay. Another reaction you see. Suppose we have Cr2O7 2 minus, and it is converting into 2Cr3 plus. N factor we have already done for this. C2O4 2 minus, and it is converting into 2CO2. N factor. Tell me, the next one is this. When this 2MnO4 minus converts into Mn plus 2 plus Mn plus 4. These are the reacting condition, guys. I'm giving you this reaction, and according to this, you have to find out the N factor. Don't think about like how do we know this. It would be given in the question. One correction I'll do here. It is not plus 4. It is plus 6. Okay. In the last one, the important one is Fe C2O4. Ferrous oxalate it is, and it is converting into Fe plus 3 plus 2CO2 . Tell me, for all these reaction, N factor. First, second, third, and fourth. You are getting 2 for the first one. Aditya, Dhyan, Ranganath. Assume this is as the first question, second, third, and fourth. First one is 6. Dan is getting 6 as the first one. First one, guys, I have already done this. Check your notes. Just few minutes back, I finished this. CR 2 minus 2 CR3 plus. Check your notes, guys. 6, 2, and 10. The last one you are getting 10. Second last one you are getting 10. Prajna. Third one is zero point 0.5. Okay. Okay. Now I'll do this. You just see. First of all, what we do, we'll find out the oxidation number. Okay, so here it is plus 6 and plus 3. So total charge is what? 6 into 2, 12. 2 into 3, 6. Change in oxidation number is 6. So n factor is 2 into plus 6 minus 2 into plus 3 divided by 1, which is nothing but 6. Am I clear? For this one, it is plus 3 for this carbon and plus 4 for this carbon, right? N factor will be, for this one, it is 2 into 3, that is plus 6 minus 4 into 2, 8 divided by 1, and that is 2. N factor negative sign has no significance. That's why I'll write only 2 here. Okay. Minus 2 will consider it as 2 only. Correct? This one, for manganese, it is plus 7 here, plus 2 and plus 6. So now you see N factor will be 2 into plus 7 plus 7 minus will have plus 2 and then minus will have plus 6. This whole divided by the number of molecules, which is 2 here. That will be 14 minus 8, 6 by 2 is 3. Right? Here iron is plus 2. Right? So this you have to understand. Iron is converting into plus 2 to plus 3. The change in oxidation number for iron is 1. And this is nothing but, if you see the anion part of it, it is nothing but C2O4 2 minus is converting into 2CO2, right? And this one we already did, n factor is 2, right? So for this the n factor is 2 and for iron the n factor is 1 because the change in oxidation number is 1. So overall n factor, if you have to find out, that will be 2 plus 1 for iron is equals to 3. So for ferrous oxalate FeC2O4 n factor is 3. This particular one is very important. You can directly memorize this particular conclusion also. Third one, using balancing. Yes, you can do that, but for that the reaction must be given. Which medium it is, it must be given. This is actually disproportionation reaction. You see, manganese, it's oxidation only. Manganese is getting reduced. Okay, the reaction overall it's not given. If it is given, then you can do the balance thing and you can find out the answer. The last one is what? It is ferrous oxalate, Fe2 FeC2O4. You see this? We have FeC2O4 and it converts into Fe3 plus 2CO2. So in this actually what happens, you see there are two atoms present in this molecule and their oxidation number is changing because ion is converting into from plus 2 to plus 3, and at the same time C2O4 2 minus is converting into 2CO2. So you see the oxygen, the carbon atom, the oxidation number of this carbon atom is plus 3 here, and for this it is plus 4. Right? So within one molecule only, there are two atoms which is present. One is iron, other one is carbon. Their oxidation number is changing. Correct? So in this kind of situation, when the oxidation number changes for more than one atom present in the molecule, what we do, we'll calculate the change in oxidation number separately for all those atoms whose oxidation number is changing. Correct? So we'll calculate the change in oxidation number of iron, which is plus 1, and the change in oxidation number of carbon, which is plus 2 here, like we did this one, right? So, and we add the total change, find out the n factor. So plus 2 change we'll have here in this reaction, plus 1 we have here, and that's why the n factor, overall n factor, will be 3. Why we divide it by 2? Because we have two molecule of MnO4. What is the formula? Change in oxidation number per molecule. So we have two molecules, that's why we divided by 2. Correct, correct. Yeah, yeah, Sahana, right. Because it has two molecules. That's why we have divided by 2. All of you understood this? All of you understood, guys? Tell me. Please write CLR if it is clear. Now, the last thing in this we have to do, and this part actually you have to memorize, guys. Okay, this you should keep in mind because in some questions you should know the change in oxidation number of different ions. First one, what happened? First one, you have doubt. Yeah, actually, the medium would be given in the question. Then only you can use electron method because if the medium is not given, then you cannot balance the reaction according to the medium. That's what the thing is. So it would be given in the question. First one, Sana, you have doubt in this one. Cr2O7 2 minus to Cr3 plus this one. Tripan got it? Understood? Tell me. Oh yeah, fine. Okay, we'll move on then. I don't know whether I have done it or not in the class. If I have done it, please let me know. Right? Okay. So this actually you have to memorize. Write down the heading. Some important oxidizing agent. Some important oxidizing agent. Their change in oxidation number you should know actually. Right? Change in oxidation number you should know. Hello. Yeah, guys, are you there? Yeah, are you there, guys? Can you see the screen now? Yeah, it will come. It will come. Give me just 1 minute. It will come. There was some issue with the network. Can you see the screen now? Okay, guys, I am sending you the link again. Okay, join the new link, all of you. Okay, did you get me? I am sending you the link again. Join the new link. Correct? Yeah, just give me a minute. I'll just send you.